So, Bismillah ar-Rahman ar-Rahim. As per the unit we are in, we started last class, yes, but even though. Small recap. Database security and cloud security, it's a context of storing data and securing the data to be stored in background. In addition to architectural design to deliver services remotely over the cloud computing scenario and mechanism. This is a scenario via which actually sets up a security on a remote service delivery based on architectural design. What does this mean? As per the diagram we see in front of us, we have a resource, let's say, store database engine, in which we are able to store and manipulate contents, data, values, metadata, and so on. But to reach such store, we have to pass through a group of layers that they give actually the chance to the end users, the front end interface, front end layer, the rights or the denials. Either you can or not. There are constraints and policies we saw in the unit number 4, the access control, the access mechanisms to award access to resources. So by this architectural design, we can understand that we cannot reach the resource from the first click. There is a limitation, there is a restriction via which we can raise up the security based on the architecture only. We can enhance further, but at least we have a first defense layer, which is the architecture, physical architecture. This is seen when we deliver resources, services remotely, whether simple database or based on the cloud computing itself. The first design that we have to set up once we talk about the database as a data store, the relational context, which is actually a mechanism we have to set up to make objects within the same database get correlated and deliver a coherent service. Remember that the database is no bulk of data set altogether. It's a group of correlated objects. Given the example of the DUA we have here, we have the students as a unit, an entity. We have the classrooms. We have the subjects and majors, departments. All of them, they are different entities that they have to correlate all together in order to terminate the electronic service delivery that we have to deliver to all the DUA users. Thus, a relation scenario has to be put in action in order to make the entities act all together. You have to understand the thing this way. If you understand it differently, if it gives you the final capability or the skills in order to correlate the entities together to deliver the services correctly without failure, without interruption, that's fine. Otherwise, you have to re-study the thing to understand what this means, relational views, relational scenario, relational database. Database here is the topic, but to relate or interrelate objects within the same one database. Yeah, actually, relational database means we are going to make objects correlated altogether. Objects inside the database is not only tables, but mainly we talk about tables. We talk about entities, which they are, whether tables of views or let's say stored procedures, user-defined functions, schemas. Schemas that they cover all actually. they can cover a group of tables, group of views, group of sort procedures. All of those objects, they have to be correlated all together. There have to be a network to interrelate all without failure. There have to be a path to lead a connection between all entities. It does not have to be a mesh network, means all entities are interrelated to each other fully. No, but there have to be a path at least to draw the constraints and the restrictions. And the path has to lead from the first till the end, till the last entity, from the first entity till the last entity. There have to be a path. Constraints and conditions, they have to be seen also. Example of see actually from, for example, this color ID table, we can go to this current build table, not direct, but through this primary table. But there is a path. Here it is. There is a path. The terminology that you have to know and to memorize very well when we talk about the relational databases. When we say that our database is relational, so very common terminology that you have to find available. We find last class, but briefly here, we have to talk about an entity. From a first view, we talk about a table. We have to talk about a record and a field. A record, which is actually one group of data related to an instance. For example, we say student profile. So the record is the profile. We say subject description, name, department, college, semester. So the details of the subject is a record, and so on. Field, the list of IDs, all the students' IDs. For example, this is a field. Students' contacts, mobile numbers. All the students' mobile numbers, all the students. So the mobile numbers, they are a field, one field. Students' emails, all the students' emails. The emails, all the emails is one field, and so on. Primary and foreign keys, this is the secret behind drawing the relation, because a primary key is a unique value that identifies an object, and this primary key, it has to be represented in the related object. Then it would be renamed to foreign key. The same primary key, it has to be available inside the related object, but with different name, foreign key, not primary key. The same attribute, which is a primary in the object number one, it is the same attribute in the related object, originally named primary key, and the related object is named foreign key. Clear? A query or a virtual table here of you, it is a table like that has values, but those values, they are a reply of a query. It is not originally available as a table inside the database, data store. So the result of a query, whatever the query is, this result is presented into a virtual table. It looks like a table to the end user, but in the back end, in the store, it's not a table. Group of values. For example, we need the ID of the student, we need the ID of the subject, the ID of the department, the ID of the college. Those are four entities IDs. Four different entities IDs. They would be displayed to the end user into one table. So this is a virtual table. but originally they are completely different. They are from, as per this example, they are from different four entities. An example of relational database entities, they look like a table, whatever. DADL, data definition language, create. Those, actually, remember that whenever we talk about a database, the unique tool that we can refer to interrogate a database is the SQL, structured query language. So it would remain the same. There are differences, there are scenarios how to apply, but it's unique. You cannot interrogate without the SQL. Whether to create or to modify or whatever, you have to use the SQL. Okay, this is the first view, which is the definition of the scenario, the data store, the remote data store, the database. What is the problem behind? Here, actually, the security view, because you are not defining databases, but you have to, let's say, apply your knowledge regarding or related to the databases to know the weaknesses, the frauds, the vulnerabilities, and how to secure them, those problems. The very famous the very famous issue related to database is the injection. And especially we talk about the SQL injection, SQL injection. This is an attack that actually is facing all databases since they are actually acquiring queries and they accept queries, they accept requests from end users, and they deliver outputs. Since there is an input point that leads to the database engine, there is a problem of SQL injection that has to be covered. What does it mean to be covered? Means this issue has to be controlled. There have to be actually an input validation in order to avoid such a problem. Such an issue, such an attack, which is the SQL injection attack, it causes numerous problems. Amongst of them, the very famous and the categories. An SQL injection might modify or delete data from an entity inside the database. An SQL injection might execute commands, lead or cause an execution of a system command to retrieve data related to the environment where the SQL database engine is running. Means related to the server. An attack on the server itself. It's a more disastrous attack. It is more disastrous than deleting even sometimes. So because we are talking about the environment, we are not limited to the engine only. Also, an SQL injection might lead into a DOS attack, which is a denial of service attack. It might cause the database to be off. It might lead into an off time. The database is not serving anybody. Anybody tries to log into the database, he cannot get connected due to such attack. A view via which we may see a path succeed in accessing a database and doing an SQL injection. So since there is a path, there will be a possible SQL injection. There are layers where we have to set different security filtration or security techniques to avoid such an attack. So an injection, in order to fail it, we have to control different layers because the injection causes, they are numerous. They are not one reason, so we can control that reason. No, we have to control different reasons. Thus, segregate the roles. It's a load balancing context. Remember the word load balancing. One of the very famous techniques that we may apply in order to succeed in the SQL injection. So this SQL injection now, how it happens. See, a query might actually be passed actually to the server. This way, we are trying to display only the first name of a student. If the first name is this value, okay, that's good. So actually, this way, we are passing a query to check if the value is the field. This value here, which is in between single quotations, use a prompt. Okay, what's the problem here? The problem is, see here, see, I'm gonna do the thing, and I'm gonna rectify it. I'm gonna return back. I'm gonna apply here instead of. Let me make a copy. Let me make a copy for all the query. Give me a second. Okay, great. So I want to make a copy of this query. Okay. Great. So see here, I'm going to modify this. I'm going to modify this is user prompt. I'm going to modify it with single quotation, semicolon, drop, let's say table, costs. Okay, minus. Great. Let me typo here to be sure. See what I typed. Single quotation at the beginning. This single quotation, it terminates the value required here. Nothing means here I'm not passing anything. It's not an error. But I'm saying that the f name is nothing. Empty. And I terminated the full query. The full query, I terminated it. And also I passed a second query that would drop a full table. Means a table would be deleted completely, dropped from the database. The table is cost. What comes after would be considered as command. So I may close my query here actually with a semicolon. Yeah. So I drop the table and I neglect all what comes after command. I put it as command. So it will not give any error. Well, what comes after is command. It's not text. This is a dangerous context. It's not unique, but this is one of the very famous techniques how we apply a SQL injection. At the same time, it can be controlled easily, but this is a concept to make you understand only. I'm going to cancel all what I did. Wait. Another type of SQL injection, which is the tautology, another category, another way, which is actually, it does not check whether the syntax is a string or not, or the search query is searching for a first name or not, but it will stop the effect and make the server validates the query, whatever is the request. We are going to check an information if of a user, if username is validated, and a password also is validated. Otherwise, no. So this is the query. We are going to do an SQL injection in order to trespass this query. What is the weakness? What is the problem? Usually the problem is because of those quotations. Those quotations. They are making trouble. They are causing the trouble. Instead of typing or letting the system read this query like it is, so the system will check the name. If the name here, this name here, what I'm highlighting now, it is from this table users or from this entity user, I'm not going to let him read what the user passed. No, I'm going to replace this user here, this inputted value from the user here, with this value here. It is set as a tautology or 1 equal to 1 attack. This query, I'm going to write it differently, make you understand. So, it's the same. It is the same. Yet, instead of typing $getName, which is actually what the user has submitted, I'm going to close a single quotation, space, and tell, oh, it's a SQL only. 1 equals 1, space, comment. That's it. So the query in new format is this thing here, up to here. So the query starts here and gets closed here. So this is the body of the query. What it has. It has to select the information from the user if the name equals what? Equals nothing, or why nothing? Because we have a single quotation that opens and closes, gets closed. If there is any value is nothing, any field which is empty here, it will display, or is equal to 1. And what is the chance or the percentage to get 1 equal to 1 false? Nothing, 0. 1 equal to 1 is usually true. Usually true. So validated. What comes after is a command. Command here. Starting the command here. So all of this is a command to the system. He will not consider it. 1 is equal to 1, true. So information will be retrieved. Of whom? All the users. Because the name is validated with 1 equal to 1. Any name available there, his information will be retrieved. Successful. 1 equal to 1 attack or tautology attack. Easy to implement. At the same time, there will be an easy input validation in order to avoid it. This is for your understanding only. It is available in our book also. Great. Let's come back. Let's continue. There are other techniques, actually, they are not unique. The 2 examples we saw so far, they are not unique, but there are other techniques that you have to go after in order to do an injection. Means actually, if you can ask yourself the question, why should I go with many types? Because there are validations. No, don't expect that the system you face, or any system you face on the internet or on the web or any remote access gives you actually WW access to a remote resource that would not actually check what you type or what you request. 100% no. there will be validation. Thus, a technique that you may apply to do an SQL injection, it would fail in so many cases. So you have to try the first methodology, the first technique. You attack definitely second technique, and then after you attack definitely third technique, until you succeed. You find a technique that it is not controlled. There is no validation towards such technique. Thus, you have to try different techniques to do an SQL injection, SQL injection attack. The tautology we just defined, it is a context of validating value 1 equal to 1 or a equal to a. The attack is clearly famously known as tautology or 1 equal to 1 attack. Before I continue, any questions, please? If you have any questions, you may ask.
No, Mr.
Okay, that's good. So I believe that everything is clear. One of the other techniques that we may refer, or an attacker may refer to do an SQL injection is to nullify a content in order to try to retrieve data from a database entity. He may nullify the query, like we did. We set a comment at the end of the query after certain true value. What comes after is a comment. The comment at the line technique is to set up immediately a comment or the content is nullified. So we just pass the comment indicator, either the minus minus or the hash. We just indicate that everything what comes after is comment. It's one of the techniques that we may refer to in order to help the system get trespass, or the system security get actually get trespassed. Another technique, the piggybacked queries. The piggybacked queries. Remember that the title can give you a hint to understand later on if you feel confused when I ask you a question in semester or some in any other location. The name can lead you to understand what is that. And here we try to pass more than one query in order to succeed in doing an injection. Like the example we saw earlier, the first one. So instead of typing only a value, we terminate the query and we pass a second query. We may pass second, third, and so on. And at the end, we pass a comment to avoid any errors. So this is a piggyback technique, or piggybacked actually queries that we can do. We can pass as a SQL injection technique or SQL injection methodology. The access control and the very famous scenario via which we have to start to set up a security versus resource, usually the ACL or the access control list that would set the politics of an organization to reach resources, to reach the organization itself resources. The access control versus database, actually, they are a group of rights to be awarded to authenticated users. With authentication, there is no access completely. So the right to be given to, or the rights in plural, to be given to the authenticated users. No authentication, there is no talk at all about the access. So nobody to be given access if he's not authenticated. Clear. We saw this in unit number 3 and 4. The rights are, or the group of rights are, they are the DML or the DDL activities to create or to insert, to delete, to update, to truncate, alter, all the SQL queries that we may pass. They are rights to be given to end user because those are the queries or requests to be passed to the database engine. They represent the rights. Actually, those rights here, they are not really to run. Remember that there are constraints, there are relationships. So based on the constraints, there will be an appropriate right to be assigned to each user or to each authenticated candidate. Those rights and those access control capabilities, they can be centralized. Means we are not going to give every single user according to his session individually in his machine only. No, by a session or by a type, we assign rights. Give you an example. If we talk about the EduWave, actually, how many students we have in University of Niswa? We have thousands. Are we go? The technical stuff is going to give users, students specifically, individual rights, student by student? Absolutely no. They will fail in matter of time. It is a huge time-consuming process. So they will do it actually in a centralized mode. They will generate a group of students, and the students will inherit the right. If he's a student, so he has the right of a student. And we saw this one actually as the role-based access control, RBAC. RBAC 0, RBAC 1, RBAC 2, RBAC 3. We saw that the inheritance in unit number 4. Yes, let's. It's a common sense understanding matter here. Yes. Still in the context of the SQL injection only, we are in face of an SQL injection technique, yes, but for a different purpose here. It's not only to delete or to, let's say, execute a system command or to cause a denial of service yet, but for an information gathering here to recognize the environment, to recognize the information related to users or to the services delivered, system itself, running tools, and so on. It's information gathering technique, inferential attack. It is a matter of transferring data from a unit to another, from an entity to another. It is by contact, by doing a reconnaissance. We saw that in lab number 1, reconnaissance attack. But from within the engine itself, the DBMS engine itself, inferential attack. Passing system commands to be executed on the server itself to gather information, system information. You have to understand it this way. Technique we'll see in future times. Any questions, please? Okay, I'm going to stop the recording. If you hear your name, please say yes. I'm going to take the attendance now.